Good morning, students. In today's lecture, we will discuss the effect of further immersion. If we are given a plane area immersed in a homogeneous liquid having the density rho, the depth of center of gravity and center of pressure below the free surface, they are given to be A and B respectively. If this plane area is lowered to further depth h without rotation, then we are to find the new position of center of pressure. So let us consider a homogeneous fluid having the density rho. This line represents the free surface of the liquid. This is the plane area S, which is immersed in the liquid. G is the center of gravity. P, this point, that is the center of pressure. The depth of G below the free surface we have denoted by A, and depth of P below the free surface we have denoted by B. Then the resultant thrust on this plane area, that is given by rho into G into A into S. Now let us suppose this plane area that is lowered down to this position without any rotation, and this depth we have taken as h. So this further immersion that will cause an increase in pressure at every point, and because the depth we have taken as h, so the increase in pressure at every point, that will be rho into G into h. And because this increase is uniform, so the total increase in pressure on this whole surface, that will be rho into G into h into s, and that will act at the center of gravity. In new position, the center of gravity is G1. So this will act at the point G1. Thus we have two forces now. One force acting at this point, which is rho into G into A into S, and one force acting at the point G1, which is rho G H S. Now these two forces, they are parallel to each other, and these are like parallel forces. So the resultant thrust that will act at a point in between these 2 points, and that point we have denoted by P2. And because these are like parallel forces, here the force is one of the forces rho G AS, and here the force is rho G HS, and these are like parallel forces, so their resultant is given by rho G S into A plus H, and this is also acting at the point P2. Now let us take x bar is the depth of new center of pressure. Now let us take moments about the line AB. So the moment of the resultant, that will be same as the sum of moments of the two forces acting at the points P1 and G1. So the moment of resultant force, that is given by force into the perpendicular distance of the force below the free surface, the distance of the this line of action of force from the free surface, that is x bar. So x bar into rho G S into A plus H is equal to the moments of the two forces which are acting at P1 and G1. Those are given by rho G H S into A plus H plus rho G A S into B plus H. From here we can find the value of x bar, which is given by taking this term in the denominator, and we can cancel out rho G and S from numerator and denominator. So we get the value of x bar from here, which is given by ah plus h square plus ab plus ah upon a plus h. So this can be written as h square plus 2ah plus ab upon a plus h. So this gives us the position of center of pressure after further immersion. We will use this formula to solve our problems. Now our problem is, find the depth of center of pressure of a triangle which is immersed in a homogeneous liquid, the depth of whose angular points below the free surface are alpha, beta and gamma. So we are given a triangle. Let us take the triangle we have denoted here by the triangle ABC. This is the triangle having the vertex A in the free surface. The depth of the vertices B and C below this line free surface we have taken as B and C. Now let us produce this line BC to make the free surface in the point E, and let us take the depth of center of pressure of this triangle is x below the free surface. Now we are to find x. As we discussed yesterday, we are to find the center of pressure of this part of this compound body. So for this we will have to find the value of thrust on the whole triangle and depth of its center of pressure, then the thrust on this triangle and the depth of center of pressure of this triangle. So we are to find the four values. Let us take P1, that is a thrust on the triangle which is the whole triangle, full triangle AEB, and P2 is the thrust on the triangle ACE. X1 is the depth of center of pressure of the triangle ABE, and X2 is the depth of center of pressure of triangle ACE. Now let us find these four values one by one and substitute in this formula. Now what is P1? P1 is the thrust at the center of gravity of triangle AEB into the area of triangle. Depth of center of gravity of the triangle AEB. AEB is this triangle. So the thrust on this triangle will be rho into G into 0 plus B upon 3. So that will be B upon 3. And area of this triangle, that will be half into base into height. Base of this triangle is AE and height of the triangle is B. And if we find the thrust on triangle ACE, that will be rho into G into depth of center of gravity will be 0 plus C upon 3. And area of this triangle will be half into the base AE into the height C. X1, which is the depth of center of pressure of this whole triangle. Because this triangle is having one side in the free surface and the vertex downward. So depth of center of pressure of this triangle, that will be total height upon 2. Height of this triangle is B. So X1 will be B by 2. Similarly for the triangle ACE. This triangle is also having one side in the free surface and vertex downward. So X2, which is the depth of center of pressure for this triangle, that will be C by 2. So we have obtained all the four values. Now we can substitute these four values in this formula, which is x is equal to P1 x1 minus P2 x2 upon P1 minus P2. So if we put the four values here, we get the value of x, which is given by B square plus BC plus C square upon 2 into B plus C. Now, let us suppose this triangular area is further immersed to the depth of alpha without rotation, and therefore we can find the depth of the new vertices. Let us take the depth of the new vertices in the new position is alpha, beta and gamma. Depth of the vertex A dash we have taken as alpha. Depth of B dash we have taken as beta. Depth of C dash we have taken as gamma. Here we can see in the figure, this is the triangle which is further immersed to the depth alpha. This is depth alpha up to which this triangular area is further immersed. Depth of B dash we have taken as beta, and depth of this vertex C dash we have taken as gamma. Now from this diagram we can see that this is B, this is alpha. B plus alpha is equal to beta, because beta is the depth of the vertex B dash. So we can say that B plus alpha, that will be beta. So from there we can find the value of B, which is given by beta minus alpha. And also again from here you can see this is C, this is alpha. C plus alpha. C plus alpha gives the depth of C dash, and depth of C dash we have taken as gamma. So we can say that C plus alpha is gamma. So from here we can find the value of C, which will be gamma minus alpha. So we have obtained the values. Now we have to find the depth of center of pressure in the new position. So by the formula which we derived, by that formula the value of x bar is given by h square plus 2ah plus ab upon a plus h. Here let us find the values of h, a and b. Now h is the depth of further immersion, which we have taken as alpha, and in this formula a is the depth of center of gravity in the original position, which was before further immersion. In that case we can see here the depth of center of gravity of this triangle, that will be 0 plus b plus c by 3. So that is b plus c by 3. B here, that is the depth of center of pressure in the original position, and we have derived it already, which is b square plus bc plus c square upon 2 into p plus c. So we have obtained all the three values h, a and b. Now we can put these values here. X bar, so x bar becomes alpha square plus 2 into b plus c upon 3 into alpha plus b plus c upon 3 into b square plus bc plus c square upon 2 into b plus c, and in the denominator we have a plus h. H is alpha and a is b plus c by 3. Now because we have to find the result in terms of alpha, beta and gamma, so let us find the values of b and c in terms of alpha, beta and gamma. Now what is b? That is beta minus alpha. C is gamma minus alpha. So b plus c, that will become beta plus gamma minus 2 alpha. B square, b is beta minus alpha, so b square will be beta minus alpha whole square. So that will be beta square minus 2 alpha beta plus alpha square. C square, that is c is gamma minus alpha, so c square will be gamma minus alpha whole square. So we can put the values of gamma and alpha. So we have obtained the values of b plus c, b square, c square. Also we require the value of term bc. So let us multiply the values of b with c. Value of b is beta minus alpha. Value of c is gamma minus alpha. So if we multiply these two terms, we get the value of bc, which is given by beta gamma minus alpha gamma minus alpha beta plus alpha square. Now it remains to find the value of this expression, b square plus bc plus c square. Now we have obtained all the three values, b square, c square, bc. You can put these three values here. So you will get the value of this expression also. Now b plus c upon 3 plus alpha. From here b plus c is beta plus gamma minus 2 alpha. So putting this value here, we get the value of this expression also, which is given by beta plus gamma plus alpha upon 3. So we have obtained all the expressions which are required in this term x bar. Now we can substitute the values, all the expressions here to get the value of x bar, which is given by alpha square plus beta square plus gamma square plus beta gamma plus gamma alpha plus alpha beta upon 2 times alpha plus beta plus gamma. So this gives us the position of center pressure of the triangle in terms of depth of its vertices. So this was the topic, effect of further immersion.